Good evening, everyone. As promised, I wanted to make sure that I give you a video that supports Chapter 7. And so what I have done is basically worked through each one of the problems for Chapter 7. Now, I will tell you that I'm going to move rather quickly through all of these problems because it's going to be an environment in which you can listen to the same example over and over if you don't understand it. So there's no reason for me to try to pace this out as if we were working in class. After you look at how the video reviews the problem and how the problem is covered, if you still have any questions, you could text me and I'll try to get with you as soon as I can to give you a little bit more of an in-depth explanation. But most of these problems in Chapter 7 are rather straightforward. So we're going to go ahead and get started on this, and we should be able to work through this rather quickly. Okay, so let's look at number 1. Now you'll notice if I put the problem underneath the camera, it's really not that clear. In the case of number 1, we need to determine the interest payment on 3 bonds. The corporate bond is paid out semi-annually, like all bonds, at 3.25% interest. There's a Treasury note at 4% and a zero coupon at 0%, because that's what a zero coupon bond means. So I'm going to work through these and we will compare them accordingly. So the first thing we're going to look at is I'm going to move the paper over so I'm working it from the edge here. The first thing we're going to look at are the corporate bonds. And I'm trying to use dark enough ink so that you can see it on the video without too much trouble. So with the corporate bonds, it's paying 3.25% a year. So if we know that these are paying out semi-annually, then we know that each 6 months you're going to get half the interest. So when I'm working with bonds, I go ahead and convert them to the interest rate to a decimal. And since we know that it's going to be a semi-annual payment, let's go ahead and divide that number by 2, which is going to give us 0.016250. And all we're going to do is we're going to take, because what we're doing is we're calculating the interest payment, a single interest payment. We're just going to take this semi-annual interest of 0.016250. We're going to multiply it by the face value, and that is going to give us our interest payment of $16.25. Pretty easy. Then we're looking at the Treasury notes. Same rules apply. We're looking at a 4%. Looking at a 4% interest rate, so I convert that over to a decimal just to make it easier to work with. And since it's semi-annual, I go ahead and divide that by 2, and that gives you, of course, 0.02 as your semi-annual interest payment, or your interest rate. We'll take that 0.02 and multiply it by the face value, or the par value of $1,000. Which is going to give me a $20 interest payment. So again, all we're doing here is calculating up the interest payment, a single interest payment, which would be a payment made every 6 months. Okay, and then the third thing says, the third question is corporate zero coupon bond maturing in 10 years. Well, the maturation date doesn't matter. The interest payment is what we're looking for, and if it's a zero coupon, there is no interest payment being made on it. Zero coupon bonds don't have interest payments by definition. Okay, so now we're going to look at number 2. Now this is kind of a silly problem, I think, but believe it or not, people miss it, so we will deal with this. It says that the bond issued by Ford on May 15th, 1997. So the issue date is May 15th, 1997. And the bond matures on May 15th, 2097. And today is November 15th, 2013. Now, I usually handle these like I would calculating somebody's age. The question is, what is the bond's time to maturity? Well, if the bond matures in May, okay, then, and today's date is the 13th, I mean, basically what we're doing is we're calculating how much time we have left. Now, this is November, so for the purpose of this problem, I'm going to go ahead and, so that I'm dealing with the same months, I'm going to say May 15th, 2013, which is going to give me that 83 years. But I've got several more months, okay? So between June and November, that's another 6 months. That's where you get the 83 years and 6 months. Okay, so now we're going to move on to number 3. All right, so for number 3, we're looking at a corporate coupon bond, which is just a semi-annual bond. The interest rate is 6.8%, and since we're working with bonds, I like to convert that over to a decimal, so we're looking at 0.068. Okay. We know that the bond is callable in 5 years, and we know that the premium is equal to 1 year of coupon payments. And so we have everything here that we need to calculate the price of the bond. Now, the philosophy is basically this. If a corporation is calling in their bonds, that means they're going to go ahead and pay the people off. So that means that they're going to have to pay off the original $1,000 per bond, and then of course there's this bond premium that they're also going to have to pay. Well, the problem tells us how much the bond premium is going to be. It's going to be 1 year of coupon payments, and we know that 1 year of coupon payments is going to be 6.8%. So if the corporate bond price is equal to principal and the call premium, which makes sense logically, we know that the principal is $1,000, and we're going to add this call premium in, a 0.068 times $1,000, which is that interest. Okay, so if we add that in, that gives us our $68. We add that together, we end up with $1,068, and so that is the price that will be paid to the bond holder. It will include the original principal of $1,000 plus the bond premium, or the call premium, of $68. Okay, so now in problem number 4, we're going to be looking at a Treasury inflation protected security. Now, in order for something to be inflation protected, it means that there's got to be some sort of measurement of inflation, and the most common measurement of inflation is what's called the consumer price index. So I'll give you a brief explanation and a very simplistic explanation of what the CPI actually is. The consumer price index is basically the total price of a basket of goods, and these are considered goods that you and I would buy pretty regularly over a period of time. So if they price out the basket of goods today, and it prices out at a particular dollar value, and then they wait 6 months and they reprice that same basket of goods and the price has gone up, then obviously we know we're in a period of inflation. If those prices go down, then we know that prices are deflating. And that's basically a very simplistic way of how they measure inflation. So when we apply it to a Treasury inflation protected security, we can't really calculate the par value of that stock because it's going to, or the par value of that bond, because it's going to change as the inflation conditions change. So we have to calculate the par value a little differently. So we know that we have a 3.125% interest rate, and I like to convert those over to decimals when I'm working with bonds. And the original CPI is 185.7, and the current CPI is 211.00. Now we can look at these two numbers and we can say, well, if the original consumer price index was 185.7 and now it's at 211, well, the prices have obviously gone up. So we know that there's going to be an increase in value or par value of these bonds, just considering the fact of the higher consumer products, or the consumer product index, or the consumer price index. And the way that's calculated is we take the current, we're going to take the current CPI of 211, we're going to divide it by 185.7, and then we're going to multiply it by the par value. Again, this is how we calculate that base par value of a TIPS. And what we get is $1,136.24. So now we want to know what the interest payment is. Now we know as a bond we're going to get an interest payment every 2 years. So let's go ahead and adjust that interest payment for 2 years. So 0.03125 divided by 2. That means that each interest payment every 6 months is going to be 0.015625. That's going to be the interest rate, or 1.56%. So we're going to take that interest payment, and we're going to arrive at that interest payment by taking our 0.015625, multiplying it by the par value, 1136.24. And that's going to give us the value of a single interest payment of $17.75, and of course that is made every 6 months. Not too bad. Okay, moving right along to question 5. Now question 5 is going to take a little bit of time to explain, but it's really not going to be too bad. The toughest part is going to be working with this Treasury note, because we're going to be pricing bonds based upon quotes. All right. So in the problem, you'll see that the Treasury note is quoted as 97:30. Now this number is set up a little differently from what we have seen in the past. So when I rewrite this quote, I'm going to write 0.97, put a little bit of space in there, put another colon. And then how do we deal with this 30? Well, Treasury notes are quoted in 30 seconds. So we're going to take that 30 and divide it by 32, and that's going to give us 0.09375. Now our natural tendency under these circumstances is to add these together, but we're not as much as adding these together as we are pushing them together, which is going to give us 0.97935. Now we're going to do this one more time just to make sure that we're clear, because Treasury notes are quoted a little differently. So let's make sure that we have this. Okay, so we have the Treasury note being quoted at 97:30. We're going to, in reading this quote, we're going to convert this over to 0.97. We keep our colons. We're going to take, because the Treasury notes are quoted in 30 seconds, we're going to divide that by 32, which is going to give us 0.9375. We're not going to add these together. We're going to more or less push them together, and that's going to give us 0.97935. That's going to be the factor that we use in calculating the par to calculate the price of the bond. Then we're going to multiply that number by 1,000, and that is going to give us $979.38. Yes, 979.38. Okay, move this over just a little bit. All right, now when we look at the corporate bonds, we're looking at something a little bit different. They're quoted at 102.95. Now, to me, this is how I handle this. I always move that decimal place over to 2 decimal points. Okay, why do I do that? Here we're saying that this corporate bond, if it's being quoted at 102.95, basically what we're saying is it's 102% of its value, 102.9% of its value. So that's 1.0295 times. I mean, it's basically the same number. So when we take this 1.0295 and multiply it by the original value of the bond of $1,000, we get the figure of $1,029.50. And the municipal bonds, very different. Let me push this up a little bit. So when we're dealing with the municipal bonds, we'll roll this up just a touch. Okay. In this problem, the municipal bonds are quoted at 101.60. Again, I convert that over to 1.0160, which basically means I'm just moving the decimal place over 2 points to the left. I'm going to take that 1.0160 and I'm going to multiply it by the par value of the bond, and in the case of the municipal bond, it's $5,000. So if we take 1.0160 multiplied by 5,000, we get an amount of $5,080. Okay, moving on to number 6. And again, I do realize I'm moving through these pretty quickly, but what I'm trying to do is get through all these problems. You can certainly watch any one of these problems over and over in the video and get in touch with me via text message if you have any problems with this, and we'll talk about it in greater detail. Okay, so now we're looking at problem number 6. I think I'm going to move over here a little bit so I got a little bit more paper. Okay. I mean, I can't stand that. All right. So what we're going to do here is we're going to calculate, in number 6, we're going to calculate the price of a zero coupon bond that matures in 24 years if the interest rate, the market interest rate is 4.1%. Okay, so we have a zero coupon bond. So we know that no interest payments are being made. We know that it matures in 24 years. And the market interest rate is equal to 4.1 or 0.0410. Okay, moving the decimal point move the decimal place over 2 points. Now I know this is going to get a little bit confusing, because if we've got a bond that's a zero coupon bond, then payments are not being made every 6 months. But for the purpose of these calculations, we're going to treat this as a semi-annual bond, even though there's no coupon. So the formula that we're going to use is present value, which will take the future value of the bond divided by 1 plus I raised to the nth, which we've seen this several times before. And in setting up this problem, we're using our future value, which is going to be the face value of the bond of $1,000. And then we're going to use the market interest rate to make this calculation right. Because again, the zero coupon bond doesn't have an interest payment that's coming in. So what we're dealing with is we're looking at market interest right here. So if we look at the market interest rate, we'll do it just like we did the other ones. We're going to take 0.0410 and divide it by 2, which is going to give us 0.02. I'm off the paper a little bit. It's going to give us 0.0205. Okay. So when we do our 1 plus I over here in the formula, we're going to have 1 plus 0.0205, and that's going to be raised to the nth. Now, because we adjusted our interest to semi-annual, we also have to make an adjustment here of semi-annual instead of annual payments. So we're going to take that 24 and multiply it. We're going to double it because of semi-annual payments to 48. All right, and what that is going to give us, we're going to take the 1.0205 and we're going to raise that to 48. Then we're going to end up with 1,000 divided by 2.648649. Which is going to give us $377.55. And this is going to be the price of it's going to be the present value or the price of the 0 coupon bond. Okay, now in number 7, again, we are working with corporate bond prices. Okay, so if we know that the current yield, which is another interest rate, it's another rate, is 4.85%, we're going to go ahead and convert that over to a decimal. Okay, and we know that our bond was quoted at a price of 102.43. All right. Now, the advice I give you on this is just based from a simplicity standpoint. If you're going, you either want to use these two sets of numbers or these two sets of numbers, so you make sure that your answer is correct. So basically, what we're going to do here is we're going to take the current yield. Now, what we're doing here is calculating the current yield. We're going to take the 4.85%, which is the coupon. No, I'm sorry. This is the coupon rate. All right, so we're going to take the coupon rate and we're going to divide it by the quote, 102.43, and that's going to give us the current yield. So 4.85 divided by 102.43, we're going to get an answer of 0.047349, and when we convert that over to an interest rate, we get 4.7349%, which is the answer that we are looking for. Now we're going to move on into the direction, we're going to move on into bond pricing on a typical model here. And I will tell you that when you start looking at, opening up my soft drink, so you're going to hear it fizz a little bit. Oh, it didn't make a noise. Not too bad. Okay, so when we have, when we're calculating bond prices, what we have to do is we have to take into consideration the payment of the bond. We have to bring back to present value the interest stream as well as the face value of the bond, and that's what we're doing here. So if we have a bond, we have a coupon rate of 6.3%. There is maturity, years to maturity. And we have a market interest rate. Okay, so when calculating the price of this bond, we're not really looking at the coupon rate. I mean, the coupon rate is important as far as what kind of payment you're going to get, but you know, we're coming into the game a little late and we're buying this bond from somebody else, so we want to set a price that takes in consideration the years to maturity and what the market interest rate is today, not what it was when they bought the bond 10 or 15 years ago. So what we're going to do is we're going to calculate the bond price by first looking at this this payment that's made of 6.3%. So if we look at it as $1,000 bond, what we're getting a year in terms of payments, we take the $1,000 face value, multiply it by 6.3%, and we end up getting an annual payment of $63. Well, we're going to get that payment in 2 installments, right? So we're going to divide it by 2, which is going to give us that payment of $31.50. And this is where we're going to adjust out what this is basically worth in terms of interest. So we're going to take 1 minus, and again, pay very close attention to where this 1 is placed. We're going to take 1 divided by, now again, we're working with this market interest rate, comes in twice a year, so if we divide that by 2, we get 10.4 divided by 2, which is going to give us 5.20% interest. Put that in a decimal point, we're dealing with 1.520, which is where we get 1 plus 0.052. And when we adjust when we adjust the interest rate to a half year, then we also have to adjust our maturity rate for half years, which means our N is going to be 30. And then we're going to divide this by 0.052. Now, I'm going to kind of move this over. We're going to block it out a little bit, but I've got to leave room to add in this second part, which is dealing with the face value of the bond, where we're going to do 1.052 raised to the 30th again. So the first thing we're going to do, we're going to deal with this interest rate right here in the exponent. You'll see that we have this here, this 1 plus 0.052 raised to the 30th here. We also have it here. So my recommendation is when you're working with a formula like this and you know you're going to need these numbers more than once, go ahead and calculate them up. So we take 1.052, raise it to the 30th. So now we know that 1.052 raised to the 30th is equal to 4.575854. All right. So now the problem looks like 1 minus 1 divided by 4.575854 divided by 0.052 plus 1,000 divided by 4.575854. Okay, so now we're going to go in 1 divided by 4.575854. Which is going to give us 1 minus 0.218538 divided by 0.052 plus 1,000 divided by 4.575854, 250 $18.53844. All right, let me move this up a little bit. $31.50. We're going to wrap up what's in the brackets here. 1 minus 0.218538 divided by 0.052. We're just bringing down that 218. We're going to multiply the 1502 number by 3150, which is going to give us 473.38.56.39 plus 218.53844. And when we add those two numbers together, we get a bond price of $691.92. And I do realize this paper is a bit at a slant. Certainly when we do the videos for next semester, I'll make sure that we get that situation addressed. Now I think that once you work through problem number 8, you're going to have these problems, number 9 and number 10, pretty much mastered, because they are exactly calculated the same way. So we'll look at number 9, and then that will 9 and 10, and we'll wrap up this video. But these last three are very, very, very much the same. Okay, here we're computing the price. We know that the coupon on this particular bond is 7.6%. If we put that in a decimal, 0.0760, we're going to be using this to calculate up part of the problem, part of the formula. We know we have years to maturity of 15, and the market interest rate is equal to 9%. And we know, because we're dealing with a bond, that we're going to be dealing with a half-year convention, which is going to give us 0.0450, which is the interest rate for the semi-annual payment. And we also know that when we set this problem up, the first thing we're going to have to do is we're going to have to calculate what that coupon value, that coupon amount, is going to be. And we also know that we're going to be dividing that by 2 as well, because we know those payments come in twice a year. All right, so if the bond has a face value of $1,000 and we multiply it by 0.038000, that's going to give us the original coupon payment of $38. And then this problem is exactly the way the other problems were. 1 plus, we're using our semi-annual market interest rate, 1 plus 0.0450. We adjusted our interest rate for twice a year, so we have to adjust our term as well to 30. And then we're going to divide it by the market. And then we're going to adjust the par value, which is also this 0.0450 raised to the 30th. All right, so we're going to come over here, 38. All right, so this 1.0450 raised to the 30th is going to be 1 divided by 3.745318, which is going to be the same number we use here. Then we're going to divide that all by the market rate. And then we're going to take that $1,000, we're going to divide it by that same 3.745318. All right, so then when we take the 1 and we divide it by 3.745318, we get 1 minus 267,000 divided by 0.0450. We're going to take the 1,000 and divide it by 3.745318. 267. Okay, now we're starting to make our adjustments. Let me push this up a little bit. All right, so now we're getting ready to make our adjustments here. 1 minus 0.267000 divided by 0.0450 gives us 16.28889. We'll go ahead and add that plus the 267 that we already calculated. When we take that 16.28889 and we multiply it by 38, we're going to get $618.97. Okay, we're going to add that 267 to it, and our final answer to this problem will be $885.98. Okay, one more time, because the last problem, number 10, is exactly like the ones that we have been working. Okay, so let's look at number 10. Again, we're going to calculate the price of a bond that has a coupon rate of 11.2. We know that that coupon comes in twice a year, so let's do this in the same order we've done it before. 11.2% converted over to a decimal. Then we divide that by 2 to give us that half-year interest. That gives us 0.0560. We're only going to use this to calculate the first part of the formula. Then when we go back and we look at, we have years to maturity, 16. And then we have the market interest rate of 6.8%. And we know that we're going to be working with this interest rate as well in 2 payments. So if we in half years, so if we go ahead and adjust that, we end up with these semi-annual figures. This is semi-annual, and as well as this one. Now, since we're going to be using the market rate in the problem, let's go ahead and do a shortcut here. We know that we're going to have to use 1 plus I raised to the nth. So if we go ahead and say 1.0340 raised to the 32nd, that's going to give us 2.915129. So I'm going to move right over here a little bit, so when it's time to push this problem up so you can see it in the camera, I'll be able to do that. Okay, so let's start with the bond price. The first thing we have to do is find out what the coupon value is going to be. We're looking at using the semi-annual rate of 0.560. So if we take 1,000 and we multiply it by 0.0560, we're going to get a coupon payment every 6 months of $56. Same formula. Now here we've already calculated our 1 plus I raised to the nth, so we know that this is going to be 2.915129 divided by the market rate of 0.0340. Then we're going to take that 1,000 and divide it by 2.915129. Now if you're not clear on where we're getting these two numbers from, the 2.915129, you need to go back and look at problems 8 and 9, because we just took a little bit of a shortcut here, but it's basically the same convention. All right, so now we're going to go through, I'm going to take this all the way. Okay, we're not going to do this in steps. So the first thing we're going to do is we're going to take 1 divided by 2.915129, which is going to give us 1 minus point, whoops, 0.343038 divided by 0340, plus we're going to go ahead and calculate the 1,000 divided by 2.915129, 343,038. Okay, in this next problem, here we go. 1 minus 0.343038 gives us 0.656962. We're going to divide that by 0.0340, which gives us 19.322412, and we're going to multiply that by 56, which gives us 1,082,055 plus 343,038 plus 343.038, 1,425.09. Let me push this up a little bit. All right, so here we took, let me repeat this part of the problem right here. We took 1 minus 0.343038, which gave us 0.656962 divided by 0.0340, which gave us inside the parentheses a total value of 19.322412. Multiply that by 56, which gives us the 1,082,055 plus the 343,038 that we got up here. We add those two numbers together to give us the $1,425.09, which is the price of this 11.12% coupon bond. Okay, so I went over these problems to help you review for the test with the problems that apply from Chapter 7. And once you take some time to review this video once, if not twice, and make sure you concentrate on any problems that you're having trouble with. And again, if after you watch the video and you look at the problems a couple times you find that you can't arrive at the correct answer, make sure that you text me and we will discuss it in further detail. Okay, thank you so much. Bye-bye.